Good morning all. Now we are discussing the third unit of the geotechnical engineering, that is compaction and stress distribution in the soil mass. So your part A of unit number third, which is concerned with the compaction, and part B, which is concerned with the stress distribution. So for part A, that is compaction, it contains, that is syllabus of the part A means the compaction, introduction of the compaction, the definition of the compaction, difference between the compaction and consolidation, then the various compaction tests, that is the standard Proctor test and the modified Proctor test, which is conducted into the laboratory, and then the concept of the zero air void line, then what are the various factors which is affecting the compaction, then the effect of compaction on various soil properties, then the field compaction methods, then compaction equipment which is used for different types of soil, then the concept of placement of water content, then how we can achieve the field compaction, then the proctor needle, concept of the proctor needle which is used for field compaction control. Okay, so what is meant by the compaction? So compaction is a method which is method in that mechanically increasing the density of the soil by reducing the air content. As we know that soil sample which consists of a three-phase system and a two-phase system. In the three-phase system which consists of air, water and the solids. So this is our soil sample. If we applied some dynamic load here, note that we are applying the dynamic load onto the soil sample, and this soil sample which consists of three phases, that is air, water and solid, due to application of this dynamic load, air starting expelled out. So as air will starting expel out, so its density also goes on increasing. So if we see in this diagram, first diagram, that is density of a soil in first diagram, that is weight upon volume, that is weight upon the first sample upon volume of the first sample. And look, if we see in the second diagram, this is a compressed soil. Due to application of this load, this soil will get compressed and it get fully densified. So its weight is goes on reducing, volume is also goes on reducing. Means in the compaction we are increasing the density, means we are increasing the density by removing this air content of the soil mass, by giving the number of blows, by using this dynamic load, or by using some rammers, or by using some machineries. That is, there are various machinery from we can increasing the density of the soil sample. So what is meant by the increasing the density? We removing removing air content, that air content, or that some air content into the soil mass by giving repeating number of blows into the soil mass. So how this mechanism of the compaction is achieved? So by this diagram we show that. So this is the first diagram, that is soil block before compaction. So this soil block before compaction, it had initial state is consist of air, then water and the solid. Then by application of the load, its volume goes on reducing. So its volume goes on reducing. So initially it is at this stage, and due to application of the load, it comes to fall down. That is air, water and solid. So that is soil after the compaction. But if you apply more load, that is we are giving more compaction. That is, here we are applying the compaction. This is a load by giving this stamping. That is, we are giving this by giving this stamping to this load, stamping, that is stamping or ramming to this load. So initially we are applying some load. Due to some load, some air is get reducing, but we are applying more load. Further its air goes on reducing. So soil block after more compaction, this is diagram, this is soil block more compaction means it's get fully densified, so this densified portion, that is reduced portion, we can add more quantity of the soil, we can add more quantity of the soil, so that density of the soil which is goes on increasing. So in this diagram we see that we are adding the quantity of the soil, that those gap which is created, so this is gap which is created by applying more number of blows. So this gap we can fill with the adding more quantity of the soil, so that density of the soil which is goes on increasing, means this soil mass is completely in densified state. So what is the purpose of the compaction? Why we do the compaction? So there are various purposes. For that purpose we do the compaction. The first purpose, to increase the strength of the soil mass, by giving the more number of blows, the strength of the soil mass which is goes on increasing, increasing. Then second one, that to reduce the settlement. Okay, so suppose this is suppose this is our soil mass, and if we applied some the load, this, and settlement means what happen, this soil mass will get fall down, ये जो soil है ये नीचे ऐसा settle हो जाएगा, यानी कि नीचे की तरफ चला जाएगा. So due to application of this compaction, this soil mass is fully densified. It contains less amount of voids, less amount of air, due to which the settlement process means falling of the soil into the downward direction will goes on reducing. And the next one, that to reduce the permeability, due to application of this more number of load, what will happen, the air is goes on reducing, means it means that the voids which is present down to the soil mass, which also goes on reducing, means the area which is comes under the soil water flow which is also goes on reducing due to so let us once again consider. So this is our soil mass which contains voids, or which contains more number of gap. Due to application of the load, what will happen, this gap which is filled up due to application of the load. So means when water comes into this soil strata, it is having less gap, for flowing from one place to the another place. So the it also reduce the permeability. So it also reduce the frost damage. Means the damage which is due to that is ice fall. Then it's also reduce the erosion which is created. Then it's also control which is undesirable volume changes. So we can add water to the lubricate the contact surface of the soil particles and improve the compressibility of the soil matrices. This compaction can be done by the following ways. It can be done either static or dynamic processes. Static means by applying the steady load, that is constant load, and the dynamic means applying the and more repetitive or by giving the dynamic effort, by giving the dynamic, or by we can call as by giving repeated number of blows. Okay, so it can be done by using either vibration technique, by using some vibrating machineries, by using impact. Impact means the falling of the one object from a certain height, that is called as impact. Then the is kneading. So what is meant by the kneading, that we see in next lecture, while we are seeing what are the various equipment that we are used for compaction which is done onto the field. At that time we see what is meant by the kneading. Then the pressure, by applying the constant pressure or by applying the varying pressure. Okay, so next term is called as consolidation. So this consolidation, it is an entirely different process than the compaction, in which we are applying the steady load, that is static load, for long duration and the increasing the density of the soil by removing the water content. So here we are doing the same thing that is we done for the compaction. So in the compaction compaction is in the compaction it consists of a 3-phase system, and in the consolidation it is a 2-phase system. So in the compaction we are applying the dynamic load. Dynamic loads means we are giving the number of blows for the short duration, and we are expelling the air. So in case of the consolidation is a 2-phase system. So in that 2-phase system means it consists of water and solid. So here we are applying the steady load means the load, and this load, steady load, means the constant load, and this load we are applying for the long duration, So here we are expelling the water, and in the compaction we are expelling the air, okay. So same process what will happen in the compaction. So same process is adopted for the consolidation. So here we are expelling water only, and in the compaction we are expelling the air and densified the soil, okay. And note that in the compaction we are applying the steady dynamic load, and in the consolidation we are applying the steady load. So in the compaction dynamic, and in the consolidation is a steady load. And this compaction is a artificial process. Artificial means we are applying the load by using some agencies, by using some instrument. We are applying the load manually or mechanically, okay. And this consolidation is a natural process, that will happen after the construction of the structure. Soil below the so any structure that will settle into the downward direction due to application of the steady load of the structure. This soil will start to fall down to some extent. So it may require some period of times, that is it may require 30 years, 40 years. So as we know that what is meant by the consolidation. So let us consider, so this is our structure, or this is our, suppose this is our structure, or this is our, suppose building. So this building is constructed onto this soil strata, okay. So due to construction of soil strata, there are two kinds of settlement will be happen. First settlement, which is called as elastic settlement. Which is called as elastic settlement, and second one is called as the consolidation settlement. So what is meant by the settlement? Settlement means this soil strata will start to fall down, or will start to settle into downward direction, okay. So what is meant by the elastic settlement? In the elastic settlement, after construction of any structure, or we can say the building, immediately soil below this soil strata starting to settle down in downward direction immediately after construction of the structure. Immediately after the construction of structure, that is called as elastic settlement, or we can call as immediate settlement, okay. But the second settlement, which is called as the consolidation settlement. But we know that after the construction of the structure, so soil below this structure or building immediately starting to settle down, which is called as immediate settlement. But after period of time soil below this structure or this building also falls to some extent, settle to some extent, but it may take period of time. That is, we can call as 30 years or 40 years, okay. So this process which is called as the consolidation settlement, यानी कि क्या कि इलास्टिक सेटलमेंट यानी क्या है कि हमने स्ट्रक्चर कंस्ट्रक्ट करने के बाद इमीडिएटली सॉइल, उसके नीचे का जो सॉइल है वो नीचे जा रहा है, तो उसको बोलेंगे हम इमीडिएट सेटलमेंट, इमीडिएटली स्ट्रक्चर कंस्ट्रक्ट करने के बाद. दूसरा होता है कंसोलिडेशन सेटलमेंट. अब हमारी स्ट्रक्चर तो पूरा कंस्ट्रक्ट है, पूरा कंस्ट्रक्ट किया हुआ है, लेकिन उसके नीचे का सॉइल स्मॉल अमाउंट से, इट इज वेरी माइनर, स्मॉल अमाउंट से थोड़ा 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 क्या हो रहा है, नीचे जा रहा है। आप कौन सा भी स्ट्रक्चर ले लो, आप अब जहाँ पे खड़े हो, कौन सा भी स्ट्रक्चर लो, वो स्ट्रक्चर के नीचे का सॉइल थोड़ा 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 क्या हो रहा है, नीचे जा रहा है। नीचे जा रहा है यानी क्या है, उसमें का जो थोड़ा अमाउंट का जो वाटर कंटेंट है वो रिमूव हो रहा है ड्यू टू एप्लीकेशन ऑफ स्टेडी लोड। अब स्टेडी लोड कौन सा है, आपका स्ट्रक्चर का स्टेडी लोड है। तो due to application of this steady load, this soil will get settle into the downward direction, settle into this downward direction. This process which is called as a consolidation, this process which is called as a consolidation. तो अब ये steady load कौन सा है, स्ट्रक्चर का है। अब ये तो जो सेटलमेंट हो रहा है और उसके में का जो वाटर है वो जो रिमूव हो रहा है, वो नेचुरली हो रहा है। वो वी आर नॉट अप्लाइंग एनी लोड, बिकॉज ये स्ट्रक्चर तो हमारा कंस्ट्रक्ट हो गए। ओके बराबर ना। सो दिस इज द नेचुरल प्रोसेस एंड द कॉम्पैक्शन इज आर्टिफिशियल प्रोसेस। सो वी सी द डिफरेंस बिटवीन द कॉम्पैक्शन एंड द कंसोलिडेशन, द डिफरेंस बिटवीन द कॉम्पैक्शन कंसोलिडेशन। सो in the compaction, first of all, so diagram is important. So first in the compaction is, this compaction is 3-phase system and this consolidation is a 2-phase system. Okay, so in the compaction it consists of air, then the water, so the middle portion is water and last portion is that is third portion, that is solids. And the consolidation it consists of water and solid only. Okay, so this compaction is a 3-phase system, consolidation is a 2-phase system, or we can also call it as a compaction is a partially saturated, as we know that partially saturated soil, that is it consists of air, water and solid, all these 3 components, which is called as a partially saturated. And consolidation is a fully saturated. Fully saturated means it consists of water and solid only, or we can also call as compaction is a 3-phase system diagram and consolidation is a 2-phase system diagram. Okay, so आपके अब ये 3 डिफरेंस हो गए। पहला डिफरेंस हो गए compaction and consolidation का, कि compaction is a 3-phase system, consolidation is a 2-phase system. सेकंड हो गया compaction is a partially saturated soil system which is applicable for partially saturated soil, and consolidation which is applicable for fully saturated soil. और थर्ड डिफरेंस हो गया आपका डायग्राम। तो आप यहाँ पे डायग्राम भी ध्यान में रखो। सो नेक्स्ट, कॉम्पैक्शन में हम क्या रिमूव करते हैं? in the compaction we are removing, because in the compaction it consists of air, water, that is air, then the water and then the solid. And in the consolidation it consists of water and solid only, So in the compaction, what do you mean the compaction? In the compaction we are expelling the air, okay, we are expelling the air by application of the dynamic effort or dynamic load. हम इसमें का एयर कुछ प्रतिशत निकाल लेते हैं। सो कंसोलिडेशन में क्या होता है? एज इन द कंसोलिडेशन इट कंसिस्ट ऑफ ओनली वाटर एंड सॉलिड, सो नो एयर इज प्रेजेंट इन टू द कंसोलिडेशन। ओके, सो अब ये हो गया नेक्स्ट डिफरेंस। सो कंसोलिडेशन में हम क्या रिमूव करते हैं? वाटर इज रिमूव। सो कॉम्पैक्शन में वाटर रिमूव करते हैं क्या? नहीं, वाटर रिमूव नहीं करते। तो सेकंड डिफरेंस इज वाटर इज नॉट एक्सपेल्ड, in the compaction, and in the consolidation water is expelled. Okay, so in the compaction we are applying dynamic load, as we studied earlier. In the compaction we are applying the dynamic load, and in the consolidation we are applying the static load, that is steady load. Okay, and so in the compaction we are applying the load for short duration. We are giving the compaction, we are giving the tamping, we are giving the ramming for a short duration or short duration by giving the dynamic effort. And in the consolidation, this steady load which is applicable for long duration. The steady load, that is the load of the structure which is a long duration, that is period of 30 to 40 years we can say. Then the soil is partially saturated, fully saturated, we are really studied. So this compaction is artificial process, means we are applying the artificial load. It can be manually or mechanically by using some instrument. Okay, and it is a natural process. It is a natural process. Consolidation is a natural process because the load of the any structure, it can be naturally applied onto the soil, and soil below this structure that can be settled into downward direction. So this compaction is a fast process, and this consolidation, it is a very slow process. As we already learned, it may take a period of 30, 40, 50 period of years. Okay, and this process is very slow, and this compaction process is very fast process. And you also know that this consolidation topic, which is we will learn in foundation engineering, that is second part of geotechnical engineering. It is also unit number 3 in the foundation engineering, that is the consolidation settlement. So now we are focusing on compaction. We are focusing on the compaction because our syllabus which is concerned with the compaction only. Okay, so we see what is the difference between compaction and consolidation, what is actually difference between compaction and consolidation. Okay, then the next one, so what are the various effects of the compaction? Okay, if there is a theory point of view, if you see a theory point of view or the theory question, what are the various most likely question? So I will share what are the various most likely question that I had already shared for unit number 1 and unit number 2. Same way I will share for unit number 3. In that, the first question is what is the difference between the compaction and consolidation. Second question is what are the various factors which is affecting the compaction. What is the various factor which is affecting the compaction. Okay, so in unit number 2, what are the various factors affecting the that is permeability. In unit number 3, what are the various factors affecting the compaction. In unit number 4, what are the various factors affecting the shear strength. So note that what are the various factors affecting is an important term. Okay, so what are the various factors affecting compaction, we learn now. So there are 4 factors which generally affect the compaction. That is first one, that is type of soil. Next, the water content, or we can call it the moisture content. Then the compaction effort, or we can call it the compaction energy. And then what are the various kinds of admixture. We know the what is meant by the admixture. That is any other alternative. Okay, that is concrete technology. We see what is meant by the admixture. Okay, for improving the compaction processes. So first one, that is the type of soil. Okay, so in that, fine grained soil will require more water to reach the optimum, and the coarse grained soil will require the less water to reach the optimum. Okay, so this fine grained soil require more water to reach optimum, and the coarse grained soil require less water to reach optimum. So what is meant by that? Fine grained soil means, what is meant by fine grained soil? Means the soil which is having diameter less than 75 micron. Means it consists of black cotton soil and silt, or we can call as a cohesive soil. And coarse grained soil means having diameter greater than 75 micron. Means which consists of gravel and sand. Okay, so let us consider. So here is a black cotton soil. Here is a black cotton soil sample mass. Okay, let us imagine, and here is a gravel soil sample mass. Okay, so while giving the tamping, it may require more water. It may require more water to get fully densified. Okay, इसको हमको ज़्यादा कम पानी डालना पड़ेगा और ज़्यादा कॉम्पैक्शन करना पड़ेगा. ओके, इट विल रिक्वायर मोर कॉम्पैक्शन एफर्ट, ज़्यादा कॉम्पैक्शन. वी आर गिविंग मोर नंबर ऑफ compaction or more number of this dynamic load. And in the gravel soil sample mass, it require less soil or less water, and
and it required less compaction effort और less giving number of blues. ठीक है, आप इमेजिन करो कि आपके पास एक ब्लैक कॉटन सॉइल का सैंपल है और दूसरी तरफ आपका ग्रेवल है तो वी कैन कॉल एज मुरुम है. तो किसको ज़्यादा कॉम्पैक्शन करना पड़ेगा कि हमको ब्लैक कॉटन सॉइल को ज़्यादा कॉम्पैक्शन करना पड़ेगा, बराबर ना. जितने हम बहुत ज़्यादा हमको उसको